America's next battlefield truck needs no driver, burns no gas, and runs entirely silent. In Ukraine, the battlefield has become almost completely transparent. The sky over the front line is so saturated with sensors and strike platforms that any movement on the ground is exposed and targeted within seconds. Small drones are highly effective for observation and rapid strikes, but they hit a hard physical limit. They cannot occupy a crossroad, they cannot evacuate a casualty, and they cannot haul thousands of pounds of heavy ammunition. Armies still have to physically move supplies to hold terrain. Because of that, ground-based supply lines remain the ultimate, unavoidable target in modern warfare. That physical reality makes legacy tactical vehicles, like the HEMT and heavy line haul tractors, massive, slow-moving targets. These exposed vehicles actually spend about 75% of their deployment entirely stationary. They sit in open fields, idling their diesel engines constantly just to power onboard command and control electronics. This chart shows how that stationary idling impacts total fuel capacity. Between 30 to 60% of a legacy vehicle's entire fuel load is burned just to keep its systems running without moving an inch. If you want to understand the technologies actively reshaping global defense, hit subscribe to Autonomous Warfare, a logistics fleet that is highly visible and deeply dependent on massive amounts of fuel is tactically unviable against modern drone swarms. To survive, the military has to rethink the truck from the ground up. To solve this, the military is bypassing the traditional, decades-long procurement cycle. Instead, they are adapting the commercial Class 4 through 6 stripped truck chassis built by the electric startup Harbinger. This platform already has a proven 450,000-mile service life in the commercial delivery sector, giving the military a rugged foundation on day one. The military takes that commercial low-cab forward design and completely removes the cab, eliminating the seats, the windows, and the driver. This schematic compares a standard mechanical layout to a drive-by-wire system. In a drive-by-wire architecture, steering, braking, and powertrain management are all controlled by electronic signals, rather than physical steering columns or mechanical linkages. Replacing those mechanical parts with a purely electronic bus is the mandatory prerequisite for plugging in an autonomous robotic control unit. A purely electric vehicle is highly limited in austere environments, where charging infrastructure doesn't exist. The military's answer is the Extended Range Electric Vehicle, or EREV. This hybrid system pairs an 800-volt direct current battery pack with an onboard internal combustion engine to deliver an operational range of roughly 500 miles. When the internal combustion engine powers down, the vehicle continues advancing purely on battery power. It emits no thermal exhaust and runs almost completely silent. This is SilentWatch. It allows the platform to run heavy sensors, communication relays, and weapons for hours, without revealing its acoustic or thermal signature to enemy tracking. The platform also functions as a mobile microgrid. An onboard AC inverter delivers 15 kilowatts of continuous exportable power, enough to run a forward operating base without hauling a separate, noisy generator. By relying on electric efficiency and generating power directly at the tactical edge, the Army estimates it could eliminate up to 12 of its 40 highly vulnerable fuel truck companies. The hardware is driven by a specialized software package called the AI Autonomy Kit, developed by Rheinmetall Canada. PATH uses an AI-enabled perception system to plan routes and avoid obstacles, even in environments where GPS is heavily degraded or actively jammed. If primary networks fall to electronic warfare, the system provides graceful degradation. The ground vehicles host resilient, line-of-sight communication relays to maintain mission continuity. This brings us to the strategic concept of attritable mass, the idea of building robots that are highly capable, yet affordable enough to risk losing in combat. This map illustrates the U.S. industrial footprint supporting that scale. American Rheinmetall is executing a $41 million capital investment across 6 manufacturing hubs in Michigan, Ohio, and Maine to secure the domestic supply chain. Technical superiority is only effective if a nation possesses the sovereign industrial capacity to manufacture it at scale, ensuring vehicles can be rapidly replaced as they are lost in the field. This cabless hybrid truck functions as a vital node in an interconnected ecosystem of uncrewed maneuver. Because the PATH software and control interfaces are standardized, they are shared across other programs, like the Heavy Common Tactical Truck and Armed Robotic Combat Vehicles. A soldier trained on one system can use the same interface for others. This ecosystem extends all the way down to the squad level with the Ground Optionally Autonomous Transport, or GOAT, program. Under this initiative, American Rheinmetall and HDT Expeditionary Systems are set to deliver 8 robotic prototypes to the Army by 2025, each capable of hauling up to 2,500 pounds of equipment over rugged terrain. Sharing the same digital brain and architecture across heavy transports, armed tactical robots, and squad-level mules creates a fully integrated, unmanned logistical backbone. All of these ground systems point toward a strategic shift away from observation-centric drone warfare, moving toward what experts call persistence-enabled maneuver. This diagram illustrates Q-confirm loops. An aerial drone transmits target data from above, while the ground vehicle navigates forward to validate the target. The ground vehicle also functions as a mobile hub and landing pad, where drones recharge and transfer data without returning to base. Combining ground endurance with aerial visibility offsets the physical limitations of both domains, extending the reach, persistence, and lethality of the entire robotic force. Thank you for joining us to explore the future of autonomous warfare. If you found this breakdown valuable, leave a like, share this video, and subscribe. Let us know your thoughts on the concept of attritable mass in the comments below, and check the description for our social links.